Good morning to all. Kapil, am I audible?
Yes.
So it is my great pleasure to introduce our esteemed guest for today's online training session, Dr. Girish Kumar Jha sir. He is a distinguished principal scientist in the Division of Agriculture Economics at ICR IRI. With a wealth of expertise in his field, Dr. Jha has played pivotal role in shaping the careers of numerous MSc and PhD students through his guidance and mentorship. In 2008, Dr. Jha was awarded the prestigious Boy Scout Fellowship by the DST Government of India. This fellowship provided him with an opportunity for an one-year postdoctoral research experience at University of Manitoba in Canada. His dedication to advancing agriculture research is evident through his involvement in various national and international collaborations. Notably, Dr. Jha was selected for News India UK Fellowship, which established the Newton Wawa Virtual Center on Nitrogen Efficiency of Whole Cropping System. This collaborative initiative funded by DBT, Government of India and VVSRC of the UK, focusing on enhancing nitrogen efficiency in agriculture practices. Recognized for his expertise, Dr. Jha serves as a valued member of the editorial board for the Agriculture Economics Research Review, a publication by the Agricultural Economics Research Association in India. His contribution to the field have been acknowledged globally, as demonstrated by his selection for international travel grants to attend 29th and 30th International Conference of Agricultural Economics, which held in Milan, Italy, and Canada, respectively. With a passion for agricultural economics and commitment to research excellence, Dr. Girish Kumar Jha continued to make significant contribution to the field through his scholarly work, mentorship, and participation in international collaborations. So now platform is yours, sir. Sir, unmute yourself, sir, please.
Thank you, Dr. Vijay, for such a nice introduction. So, a very good morning to all of you. And so directly, I'm trying to share my slides. And hope slides are visible to one and all.
Yes, sir.
Okay, good. Okay, good. So, I think this lecture is scheduled for 2 hours. So first 1 hour, I will try to have a kind of a glimpse of the basics of correlations and regressions. And then another 1 hour, Dr. Kapil, he would like to have a kind of hands-on experience with our packages. And of course, I believe most of you are faculty of this university, and some of you may be the students. You are free to stop me at any point of time wherever you feel I'm going fast or I'm going slow. So since Dr. Vijay has already given a very long and what is a kind of an excellent introduction. So needless to say that I'm posted at Indian Agriculture Research Institutes in the Division of Agriculture Economics. And I am fortunately that one of my best student is one of the coordinator for this training program, Dr. Kapil Choudhary. He did a master's and PhD under me. Okay, so we are going to talk on correlation and regression. Everything is fine. I hope I'm audible, isn't it? Because
yes, sir. Yes, sir.
Okay, good, good. So basically, if you look at the outline of this, what I'm trying to have is that what is the basic need of statistics? Why one should learn the statistics? And then what are the methods of data collections? And then what are the scale of measurements? If you get the data, what is the descriptives, how you describe the data, and then coming to the correlations and regressions. As you know, simple, the basic understanding of the statistics is it is a science which deals with the collection. You try to collect the data, you try to compile the data, analyze the data, interpret the data. That's all. This is a simple thing. So by definition itself, अगर आप इस definition को ही देखेंगे, तो you should understand that everyone who is in the branch of anyone interested in the branch of science or anyone interested in any area of study, if he's dealing with a quantitative data analysis, he must have to have a basic understanding of a statistic, because if you want to carry out any quantitative research, then you need to collect the data, you compile those data, and you analyze those data, and finally you need to interpret the data. Now, when it comes to the collection of the data, how you can collect the data, basically there are only two ways of collecting the data. I'm not saying it's a primary or secondary. The data can be collected only in a two ways. One is, I'm sure that you would have already had a lectures on design of experiment, or you will be having a lectures on design of experiment, sample survey. So data can be collected. You see, if you are a plant breeder, if you are an agronomist or any, so what happens? You develop a variety and you want to test that variety with the existing variety. When you develop a variety, you want to test with the existing variety. What you want is that the difference should be only between your genotype and the existing genotype. All other externality, be it a soil type, be it a package and practice, any other things should be a kind of a control. So you try to design the experiment. You try to carry out an experimental design. You try to design an experiment so that all other externalities should be controlled. Only the difference between your genotype, the variety which you have developed, and the existing variety or genotype of the existing variety should be comparable. So you try to control it. So that's why you go for a design experiment. But in social science, be it in economics, be it extension and all, population exists in its own way. You do not have any control on the population. So there you go and collect the data through sample survey. Now, when you talk of experimental design, as I said, that you are designing the experiment, you have a complete control on the experiment. How you design the experiment, because you want to have a complete controlled conditions. I'll say that something. So how to control the conditions? So there are three basic principles of design: randomization, replication, and local control. Simple. Randomization means you try to allocate your treatment randomly to the different experimental units. Of course, why you do it? Because you want to have an objective comparison. If you are a statistician, you want to have that observation should be independent, but otherwise, as a applied statisticians or as a plant breeder or any agriculture expert, you just want that there should be an objective comparison. There should not be any kind of a bias, and that's why you go for a randomization, or anywhere whenever you go for a lottery method. Basically, you want to have an objective comparison. Then you want to replicate it. This replication means number of times a unit experimental treatments will be done. So you just want to, like you see any exams, if it is being done twice or thrice, only to have a kind of an average, so that it will provide an estimate of the error variance. So estimates, because in one time one can go wrong, second time. So you try to take a kind of a replication data. And the third thing is that local control and error control, because you try to increase the precision by choosing the appropriate type of experimental. Like when you go for an RBD, randomized block design, what you do, you are going for a blocking. You do the blocking, and blocking is always being done in the perpendicular to the fertility gradient. So that all the units in a particular blocks are homogeneous in nature, or of same nature. So these are the three basic principles of design experiment. You will get a detailed discussions on that, and then we go for an experimental design. You go for a complete block design. The name itself, it said that in each block, all the experimental materials should be there. Be it a completely randomized design, be it a randomized block design, be it a Latin square design. You go for an incomplete block design, be it a balancing complete design or partially balancing. I'm going a bit fast because I know that these things would have been repeated. I would have covered or will be covered. Now in sample survey, again, you have in a population. Population depends on the aims and objectives of the survey, whatever may be your aims. If your aim is just to understand the standard of living of a whole scientist of a particular Jodhpur University, that is your population. And then from a population, you try to collect a part of the population. A part of population means not complete population, not complete enumeration. And on the basis of that part of population, you try to infer about the whole population. That is what is the sample survey. The challenge is that the sample which you are selecting, are they really representative of the whole population? That is one of the challenge. And then how to make a statement about the population on the basis of that particular sample. So whenever you go for a sampling, you have a random sampling. Generally, you say probability sampling. There is a random mechanism to it. And then there is a non-probability sampling. That is purposive sampling kind of thing. And of course, a common perception is random sampling is always a equal probability sampling. No, if you go into detail, you have an equal probability sampling and unequal probability. Why? Because sometimes, suppose if you have to select 10 villages and there are 5 villages are very large and some of the villages are very small, you would like to have, suppose if you want to estimate that how much food should be distributed, suppose distribution of some grains or anything, then you would like to have that the more probability should be given which has got a larger size. So in that case, you go for an unequal probability sampling. Essentially, what I am trying to explain is that in why we go for probability sampling only because of this, we try to estimate the margin of the error. We try to estimate that how much wrong we can go. You see, anyone can guess anything, but what is that suppose if somebody is asking you what is the charge between kind of say IRI and airport of Delhi, you can say 500. Then you will, but it's not that. Generally we say 400 to 500. But if somebody is saying 500 and 1000, it doesn't matter because you see 500 and 1000, so variation is too much. If you are saying 400 to 400, 500, this means he can guess that, okay, at either 400 or 500. So the standard at 450 plus minus 50, you can say. So either 400 or 500. But if you're saying 500 plus minus 500, like, so something like, so what is the margin of error you are associating with the estimates? That is more important. And that is why we go for a random error sampling or a probability sampling. Is it fine so far?
Yes, sir. Yes.
Okay, good. Now, so these are the two tools or techniques with us to deal with collection of the data. Now, simple few glance I will have it, like you always talk of variables. So what is a variable? Variable is any characteristic, any traits, any attributes of a germ plasma, or anything that can be. Stem pigmentation, it is an example. Seed color, seedling vigor, seed per pod, plant height, yield per plant. So, but whenever you talk of a variable, it can be quantitative and it can be in qualitative in nature, isn't it? So when you talk of a quantitative variables, again you have kind of a discrete or a continuous, like plant height, yield. These are a continuous. And but if you talk of seed per pod, or if you talk number of publications, they are discrete. Qualitative data like stamp pigmentation or ordinal data and all kind of. Why we are interested in that? Because as a statistics, you have to understand that what is your scale of measurement. Whether you get a nominal data, you get an ordinal data, you get an interval data or ratio scale. The treatments, that analysis will be different. In case of a nominal data, suppose you do not know, suppose only you have a gender data, male or female, or if you simply have an stem pigmentation is absent or present, you cannot carry out all kind of analysis. So this is what is known as nominal or categorical. It's a minimum level of information you are having. But more than that is that, suppose if there is an order in also in the data, like if I have a seedling vigor, I know poor, medium, good. And I also know that poor means or a small, medium, large kind of a farmers. So small farmers are small, then the medium, then the large kind of thing. So the order is also there. So there is a different kind of statistics being used for this. And of course, like interval scale, which is not very commonly used, but like years. Here the difference carries a meaning, but ratio does not. Like if suppose you have a 2007, 2020, and if you divide, then it does not carry any meaning. And what is ratio scale? Whatever variable you are getting, be it a plant height, be it a yield, all these variables are in a ratio scale. Of course, you can see that depending upon the scale, suppose it is a nominal data, then only you can calculate percentage, how much male is there, how much female is there. I guess hello.
Hello, sir.
I'm audible, Kapil?
Yes, sir.
Current has
Audible,
gone.
sir.
Okay, good, because there was a power cut. Okay, good. So if there is a nominal scale, what happens is that you can only calculate frequency, you can calculate percentage, or you can calculate the mode, or only chi-square. So what I'm trying, if suppose you have an ordinal data, you can go for a median. If you have a ratio data, means you can do anything and everything, whatever statistics you know, be it a descriptives, be it a copy, measures of dispersons, be it a correlations. So since we are dealing with suppose correlation regressions, and you see that I'll discuss in detail that if suppose there is an ordinal data kind of data, rank data is there, then usual correlation will not work there. We'll go for a rank correlation. So you have to understand that what is the scale of measurement of. So the moment you get the data, as I said, you get the data, collected the data, then you start compiling the data. And I'll be showing you some of the comparison, like you go for a histogram, you go for a box plot, and all kind of things. Then the first thing what you do is that a univariate analysis, like whatever, suppose if you have a plant height, if you have a plant weight, anything, grain weight, you go for a single univariate, means single object variables are there. You can go for a, then you can have a two variables. You may be having the plant height and as well as a grain weight or yield. So then you can consider as a bivariate analysis. So univariate analysis means you have a single variable. Bivariate analysis means at least you have two variables, and of course they are influencing each other. Then you can think of correlation, regressions, and all kind of things. And if suppose if you have a multiple variable, then you can talk of a multivariate analysis, and you are talking of cluster analysis, principal component analysis, factor analysis, and all kind of things. And in statistics, there are only two things. One is estimation kind of thing, and one is testing of hypothesis. Now, the first thing, the moment you see, when I came over here, what was done? Someone had introduced me. Now, if I have been introduced, then you understand or realize, okay, he is that person. So the moment you collect the data, we need to describe that data. And that's why we talk of a descriptive statistics. So the first thing is that you see, you have collected the data. Now you, wherever you go, first thing is that is the introduction. In fact, I should have, I have been introduced, and I know I am aware about the kind of a trainee. Otherwise, mostly we go for a round of introduction also, the trainee, who is who is. So similar exercise is being done with the data also. That the moment you get the data, don't start doing analysis. The first analysis is the descriptive statistics. You try to describe the data. How will you describe the data? So you try to find out the measures of central tendency. Because wherever you go, आप कहीं भी जाते हैं तो पहले आप पूछते हैं, मान लीजिए कि ये गांव या विलेज या स्कूल कैसा है, तो वो आपको बोलता है अच्छा है, खराब है. तो ये अच्छा खराब क्या है? अच्छा खराब मतलब वो अच्छा है, मतलब स्कूल अच्छा है, मतलब ये नहीं कि 100% स्टूडेंट अच्छा है. इसका मतलब मोर देन 50% स्टूडेंट्स अच्छे हैं तो अच्छा है, मोर देन लेस देन, अगर 50% खराब है तो खराब है. तो यू ट्राई टू फाइंड आउट द सेंट्रल टेंडेंसी. टेंडेंसी क्या है डेटा का? मेजर्स ऑफ सेंट्रल, व्हाट इज द टेंडेंसी इनटू दिस. तो यू ट्राई टू कैलकुलेट द एवरेजेज. हम किसी भी क्रिकेटर के बारे में बात करते हैं, देन वी ऑलवेज उसका एवरेज क्या है, उसका मीन क्या है. Of course, again in average you may be talking of arithmetic mean, geometric mean, harmonic mean, but in general we try to talk about. So the moment you get the data, you try to calculate the mean, median, and mode. Of course, as I said, that they again are applicable in different situations. Mode kahin pe lagu hota, median ordinal case pe, but basic descriptives we need to get the central tendency of the data. Once you get mean, median, and mode kind of things, then आप कभी-कभी देखते होंगे that cricket player, two cricket player, they have got the same averages. आप किसको select करते हैं? You select that जिसका consistent है. हम बोलते हैं कि ये reliable है. Reliable है मतलब वो more consistent है. तो then we go for a dispersion. How the data is dispersed, how they are scattered data. वो बहुत condense है या dispersed है. Then we go for a measures of dispersion. And what are the measures of dispersion? One simplest measure is range. Minimum value and maximum value. We go for a mean deviation, we go for a variance, we go for a standard deviation, and all kind of things. But since data, what the variables you are going, some of the variables may be in millimeters, some of the variables may be in kg, some of the, how will you compare that? So for that, you cannot go for a central tendency. क्योंकि कोई डाटा ग्राम में है, कोई डाटा किलोग्राम में, कोई डाटा, So you cannot go for a dispersion. For that, there is a coefficient of variation, CV. So CV is unit free. You know that a standard deviation is expressed as a percentage of the mean, and it is independent of unit of measurements. And that's why you can compare between different populations. So first, you have got a first order statistics, that is mean, measures of central tendency. Then you have got a dispersion. Then you see that whether data is skewed or not. If it is a normally distributed data, then there will be a symmetrical distribution. This means first graph, if you look at this, they are symmetrical distribution. Here in normal, like in normal distribution, normally is a symmetrical distribution, mean is equal to median equal to mode. But it can be a positively skewed distribution where mean is greater than median. Positively skewed distribution matlab what? It simply means that low values of variables are bunch close to the mean, but high values are extended. So by seeing this, what you can see that it is a positively skewed, this is a negatively skewed. So in case of this, by seeing this data, you can very well know that what kind of data is there. So from a population which you have brought, even if you suppose you have selected a sample or any such kind of, or if you have a kind of an experimental data, you can know that whether data is skewed or not. Depending upon that, you can go for a appropriate statistical tools. Then the fourth and the last measures which you go for is kurtosis. So kurtosis gives you the information on the basis of tails. Normal distributions is mesokurtic. So this is mesokurtic, this is leptokurtic, and this is platykurtic. So depending upon that, and so this leptokurtic is considered as a positive kurtosis, platykurtic is considered as a negative kurtosis. So whenever you get the data, you must try to have a descriptive of it. And when I say descriptive of it, only you have to understand first order moments, that is measures of central tendency, second order moments, that is dispersion, skewness, and kurtosis. If you know all these four order moments for any data set, this means you know anything, everything about the data. Now you are completely aware about the data. Yes, this data has got this much averages, this data has got this much variations. So if you are talking of several germplasm are there, you have got, so this is the average yield, and this varies from this to this. And the data is skewed, means most of the variables are like germplasm has got lower yield, or then platykurtic and all. And then now important thing comes is whenever you try to go for analysis of the data, what comes is that what is the type of data? So essentially there are two types of data which we are talking of, cross-sectional data and time series data. But then when we try to combine this, then it becomes a pool data. And a particular case of pool data is panel data or a longitudinal data. So what is cross-sectional data? If you look at the cross-sectional data, suppose if I take a particular point of time, it is a cross-sectional data. आप एक पर्टिकुलर पॉइंट ऑफ टाइम में सपोज एनएसएसओ का कंजम्पशन एक्सपेंडिचर है, तो अगर आप किसी क्लास में जाते हैं एंड इफ यू टेक ए मार्क्स ऑफ ऑल द स्टूडेंट्स, तो वो आपका एक क्रॉस सेक्शनल डेटा सेट होता है, ठीक है कि नहीं, एक पर्टिकुलर पॉइंट ऑफ टाइम में, ठीक है। आप अगर आज इंडिया के डिफरेंट स्टेट्स का फूड एंड प्रोडक्शन ले रहे हैं, तो ये क्रॉस सेक्शनल डेटा होता है, एक पर्टिकुलर हाउस होल्ड, इट्स ए क्रॉस सेक्शनल डेटा. ओनली थिंग इज दैट it is assumed that the data had been collected through random sampling. This is a basic assumption of this, and here the order of the data does not matter. आपके पास 20 households का डेटा है, आप 10 वाले को 2 पे रखते, 2 वाले को 20 पे रखो, कोई अंतर नहीं पड़ता. Hope all of you understand Hindi. Fine. ऐसा तो कोई इशू नहीं है ना?
No sir, ये mix है जरूर, कोई issue.
Good. So then second is the time series data, means data taken over time. आपका प्राइस डेटा होता है, डेली डेटा होता है, वीकली डेटा होता है, स्टॉक प्राइस हो, वेदर डेटा है, कोई भी डेटा है जो टाइम ओवर टाइम लेता है. ऑफकोर्स ईसीजी डेटा नहीं, जो आप हॉस्पिटल में जाते हैं और इलेक्ट्रोकार्डियोग्राम का डेटा होता है, वो डेटा हम डील नहीं करते, वो कंटिन्यूअस डेटा होता है. हम केवल डिस्क्रीट डेटा की बात करते हैं, जो आपका प्राइस डेटा है. ये भले सेकंड का भी डेटा हो स्टॉक प्राइस का, लेकिन फ्रैक्शन ऑफ सेकंड्स में जो गैप होता है उसको हम मानते हैं, भाई नैनो सेकंड में ही गैप होता है. लेकिन ईसीजी में कोई गैप नहीं होता, अगर गैप हुआ तो गया काम से. तो ये आप हमेशा ध्यान रखिएगा कि हम टाइम सीरीज डेटा करते हैं, लेकिन हम डिस्क्रीट टाइम सीरीज डेटा की बात करते हैं। ठीक है, आपको उतना जानने की कोई जरूरत नहीं। और हम ये डेटा का फ्रीक्वेंसी हो सकता है, मे बी डेली डेटा, मे बी वीकली, मे बी मंथली, मे बी एनुअल डेटा एंड ऑल काइंड ऑफ थिंग। ऑफ कोर्स टाइम सीरीज डेटा का जब हम बात करते हैं, व्हेन वी आर टॉकिंग ऑफ एग्रीकल्चर, वी आर टॉकिंग ऑफ ए सीजनल डेटा। तो लाइक अगर मान लीजिए कि आप राजस्थान का 10 साल का डेटा लेते हैं, इट इज टाइम सीरीज डेटा। सपोज आप अगर 2000 से 2020 तक का फूड ग्रेन प्रोडक्शन का डेटा ले रहे हैं राजस्थान का, तो वो टाइम सीरीज डेटा है, बिकॉज डेटा इज टेकन ओवर टाइम। नाउ अगर हम मान लीजिए 5 स्टेट का डेटा और 10 साल का लेते हैं, अगर हम पूल कर देते हैं, तो वो हो गया फुल डेटा। मान लीजिए कि राजस्थान के 5 डिस्ट्रिक्ट का डेटा हम 10 साल का ले लेते हैं, तो वो हो गया फुल डेटा। और एक जो हम लॉन्गिट्यूडनल डेटा की बात कर रहे हैं, पैनल डेटा की बात कर रहे हैं, उसमें जो हाउस होल्ड, जो स्टेट हम लेंगे, उसी को ओवर टाइम लेना है। दैट इज व्हाट, उतना फाइन जाने। नाउ कमिंग बैक टू द टॉपिक, जो हम टॉपिक डिस्कस करने आए, वो कोरिलेशंस और रिग्रेशन। तो मैंने आपको पहले बता दिया कि आपके पास इफ यू हैव ए यूनिवेरिएट डेटा, देन आप उसकी टेंडेंसी देखेंगे, एवरेजेज, मीन, मीडियन, मोड देखेंगे, डिस्पर्सन देखेंगे, रेंज देखेंगे, स्क्यूनेस देखेंगे, कर्टोसिस देखेंगे। नाउ सपोज यू हैव डेटा ऑन 2 और मोर देन 2 वेरिएबल्स। अगर आपके पास 2 वेरिएबल का और 2 से ज्यादा वेरिएबल का डेटा है, देन यू आर टॉकिंग ऑफ कोरिलेशन एंड रिग्रेशन एनालिसिस। सपोज you have data on yields as well as pod per plant. You have data on plant height and yield. You have data on days to 50% flowering and days to 50% maturity, or number of branches per plant and yield. Any such, then you try to understand the relationship between these two data, that how number of pods is related to the yield, or how fertilizer dose is related to the yield, how plant height is related to it. If you try to understand the relationship between any of these things, then you are going for a correlation regression. Correlation regression का सबसे बेसिक जो टूल्स है, वो है स्कैटर प्लॉट। और ये जो स्कैटर प्लॉट होता है, या स्कैटर डायग्राम होता है, ये सिंपलेस्ट वे ऑफ रिप्रेजेंटेशन। इसमें हम कुछ नहीं करते, हम एक्स एक्सिस पे एक वेरिएबल को लेते हैं, वाई एक्सिस पे दूसरे वेरिएबल को लेते हैं और प्लॉट करते हैं। So you have an x-axis, you have an y-axis, and you go on plotting it. आप ये देख सकते हैं कि when this kind of relationship is there, this means what happens? X increase कर रहा है. If you look at it, X is increasing because यहाँ X का value यहाँ, so X is increasing but Y is decreasing. So negative relationship हो गया, तो इसको बोलते हैं negative correlation. तो इस तरह का ग्राफ जब भी होगा, एक वेरिएबल बढ़ रहा है, दूसरा वेरिएबल घट रहा है, दिस मीन्स देयर इज ए नेगेटिव कोरिलेशन। ठीक है, बट यू कैन सी दैट दिस आर कंप्लीटली ऑन वन लाइन, देन इट इज परफेक्टली नेगेटिव कोरिलेशन। बट दे आर नॉट ऑन द वन लाइन, बट थोड़ा मोड़ा एक ओवरऑल पैटर्न तो नेगेटिव है, बट नॉट एवरी ऑब्जर्वेशन आर ऑन द लाइन। तो कोरिलेशन तो नेगेटिव होगा, बट नॉट एग्जैक्टली 1 होगा, बिकॉज यू नो द रेंज ऑफ द कोरिलेशन इज -1 to 1. Extreme correlation will be -1, negative, perfectly negative correlated, and perfectly positively correlated +1. And suppose there is no relationship, then you look at it, there is no pattern, there is no relationship. By increase in one does not have any change in change in one does not have any change in other, then you say correlation at 0. Now here if you look at it, that if one is increasing, other is also increasing, so that is what is a positive correlation. And since they are online, so R is perfectly positively correlated, but they are increasing overall, but they are not on a kind of a line, so its correlation is very low, and again there is no correlation. So you have a linear relationship. Generally, whenever we talk of a correlation, it is a linear relationship, okay? And you can have a curvilinear relationship, you have a different kind of a, but usual correlation only measures the linear relationship, not the relationship. So if they are in line, so it is positively, strongly positively correlated, it is strongly negatively correlated. And if they are dispersed, then it's a weak relation. Positive relation is there, positive correlation, but positive weak relations is there here, negative weak relations is there, and of course here there is no relationship. Now how do you find out the correlation coefficient? So as I said, it is a measure of the strength and the directions. There you get here two things. If you see here, you get correlations, you get two things. One is directions, whether it is a positively or negatively. Positively matlab they will be going in the one same direction. If one is increasing, another is should also increase. Negate, and if one is decreasing, another one is also decreasing. So direction should be same, then it's a positive correlation. Be it both are increasing, be it both are decreasing. If they have an opposite directions, one is increasing, another, then there is a negative correlation. So you get two things. One, you get the directions, another you get a magnitude. You see both are negative correlation, but here the magnitude is high and here the magnitude is low. So when you estimate the correlation coefficients, it measures the strength and the direction. Strength, when I'm saying it's a magnitude and the direction of a linear relationship. You see, the moment you try to say correlation means it is a linear relationship. If there is no correlation, that does not mean that there is no relationship. There will be a relationship. अगर आपके डेटा में correlation 0 आ गया, does not mean कि वो they are not related. No, they are related, but they are not linearly related. They may be having any other relationship other than the linear relationship. They may be curvilinear, they may be non-linear, and all kind of things. So correlations only measures the linear relationship. अगर कोई और relationship होगा तो आप उसको correlation से नहीं find कर सकते. So correlation coefficient जो होता है, this is nothing but what happens. You see, अगर आप इसमें देखेंगे तो ये क्या है? This is a kind of quadrant. In fact, x-axis and y-axis में 4 quadrant होता है, first, second, third, and fourth. Of course, for convenience, we have shown only in the fourth one quadrant, first quadrant. But this data can be in first, second, third quadrant. Overall, किस data कैसा है? So this formula may be looking complicated just for computation. Basically, correlation is nothing but covariance. जब सेम वेरिएबल x एंड x के बीच में हम देखते हैं तो वो वेरिएंस हो जाता है, और दो वेरिएबल के बीच में देखते हैं तो वो कोवेरिएंस. सो कोरिलेशन इज नथिंग बट कोवेरिएंस बिटवीन टू वेरिएबल डिवाइडेड बाय स्टैंडर्ड डेविएशन ऑफ x एंड स्टैंडर्ड. सो कोवेरिएंस जो है that is important, and then you try to standardize it to it's a standard deviation of both the variables. So, and this formula is just for computations. You need not have to worry about it in this era of computations. You know that you have a kind of computers. By click of mouse, you will be able to get everything. So here you in numerators you have a covariance, and denominators you have a standard deviation of x, both the variables, standard deviation of both the variables. And as I said, the range is always between -1 to 1, and undoubtedly, if it is -1, it is strongly negatively correlated. It is for +1, it is strongly positively correlated. So just for simplicity, it had been explained that when you are saying this is the notation for sum, so it is sum of x. This is notation for summation. So sum of y variable. So suppose there are two variables. So you sum the first variable, you sum the second variable, you have a cross product and sum over it, you square it and then take a sum, you square it second variable and take a sum of it, and then you use this. So this had been done for a simple example, just for illustration. You have an x variable, you have an y variable, whatever variables are there, x and y, you take a cross product. Now sum over x, sum over y, sum over x and y, and sum over x square, sum over y, and just put all these value in this formula. And but you need not have to do this. Dr. Kapil will show you in R packages, and otherwise this correlation you can even find out in the Excel. But you must know that why or how it is being computed. That just an understanding, not that you should know that how to calculate it. No, it's none of your business and need not to be. But you must know that, so that will give you, that will instill a confidence in you that you know it. So correlation is simply a linear relationship between any variable, and correlation coefficient is indicate the strength, that is magnitude, as well as directions of that relationship. Fine. So if correlation coefficient comes 0.986 and it is a positive, so naturally you will say that there is a strong positive correlation. A strong means it's close to 1, so between x and y. So one example has been given here just to understand it. Of course, as I said that just to show that suppose that you have that, suppose there is on a Monday there is a test, and on weekends students are watching the TV. So is there any relationship between the hours they are spending on TV and their scores on the Monday? So this is what is trying to have that number of hours of 12 different students. They are 12 different students. They watch television during the weekends, and the score of each student who took a test the following Monday. So first you have to display the scatter plot, and you have to calculate the correlation coefficient. So how to display? As I said, anything you plot on x-axis, anything plot on the. So these are the hours of watching TV, and this is the test score. So if with this data, if you look at this, that 0 hours was the students who had watched 0 hours had scored a 96 mark. So for 0, it's a 96 mark. If he had watched 1 hour, he has got a kind of an 85 marks, like that. So for x-axis, there is a kind of an hours, and y-axis, you have gotten a score, and you have got. Now, even if you are not calculating the correlation coefficient, one can very well plot like line like this. So this means it clearly indicates that there is a negative correlation. So from this visual graph or a scatter plot or a scatter diagram, what you can understand is that there is a negative relationship between this. But if you want exactly how, what is that coefficient, then naturally you'll have to go for a calculation. So first thing is a visual. So whenever you go for in a plant breeding and all kind of things, you just try to see this, that which are the traits are positively related to the yield, which are the traits are negatively related to this. So that will help you in kind of a different kind of an analysis. So again, same kind of exercise has been done for different hours, different test scores, and then cross product, square, and all kind of things. And naturally, as I said, the data itself says that there is a kind of a negative correlation. So if you look at it, there is a negative correlation, and of course, it looks that there will be a kind of a high value for this, but exact value you cannot know from the that you will have to calculate. So if you spend more time on watching TV during weekends, and if you have a test in the next Monday, naturally you are expected to get a less mark. So more time you spend on TV, watching TV, you will get a less mark. So this is a negative correlation. One, if you are increasing, another one is going to be decreasing. That's all. So there are different type of correlation. Now, just now we talk of a simple correlation. When you are trying to find the correlation between only two variables, what I was doing now is known as a simple correlation. Of course, we also say Karl Pearson coefficient of correlation because Karl Pearson gave this correlation. And as I clearly said that it only linear relationship, it only measures the linear relation. Then there is a concept of multiple correlation. In real life situation, you always go for a multiple correlation. Here, correlation between one variable and a group of variables. Suppose you may be interested to know what is the correlation of days to flowering, pod per plant, plant height, 100 seed weight on the yield of a crop. This is what you see. You may be interested in yield of a crop and days to flowering. You may be interested on yield of a crop, pod per plant. But you may be more interested that how the yield of your variety is depending upon the days of flowering or yield of a particular crop. Depends on days of flowering, pods per plant, plant height, 100 seed weight, all these kind of things. This is what is known as multiple correlation. This is what is known as multiple correlation when you are trying to find out the correlation between a single variable with a set of variables. That is what. Of course, in case of correlation, as such, there is no concept of dependent and independent kind of a concept. You have two variables, anyone you can use. So it's not like an dependent. Similarly, here when you are talking of a multiple correlation, so you have one variable and you try to have a correlation with a set of another variables. And then third concept is partial correlation, isn't it? Partial correlation means if you have two variables, then you have only simple correlation. Partial correlation there does not. But suppose if you have three variables or three variables, now you want to find out the correlation between these two. then correlation between these two after eliminating the effect of the third variable is known as a partial correlation. If you have 4 variable, again, simple correlation between any two after eliminating these two effects is a partial correlation. So in partial correlation, you if suppose 3 variables are there, you can have a partial correlation between any two. Okay, any two variable, and after eliminating the effect means you are controlling the another variable, any additional variable. If you have 3, you are controlling 1. If you have 4, you are controlling 2. Whatever may be, if you have n variable, you are doing this 2, and you are controlling n minus 2 variable. Then there is a rank correlation. Rank correlation was given by Spearman's, and it is a non-parametric. Non-parametric means it has got a less assumptions rather than the parametric one. Suppose you have a qualitative traits. You are a judge and you are going for a kind, and suppose you are having an intelligence test also, and you have a test for beauty also. If you want to see that how the brain and beauty are related, so you are ranking the intelligence also, you are ranking the beauty also, and then you try to find out the correlation. Here it is a, so if you have a quantitative variable, you can always rank them. But if you have a ranked data, you cannot go for a quantitative. So if you have a ranked data, you cannot find out the usual correlation. So this is the kind of a mistakes which we generally do, is that we don't see the data. So a scale of the data, here itself, I'm trying to say that a scale of measurement, which type of data. So one is cross-sectional time series and all kind of things. Another is a scale of measurement, whether you have a nominal data, you have an ordinal data, you have an interval data, you have a ratio data. So depending upon the data, for qualitative data, other kind of correlations are there. I'm not going to talk about that. There are correlations available for that. But if you have a kind of a ranked value, you go for Spearman's ranking. So suppose if you have a data on day to 50% farming, plant height, day to maturity, 100 seed weight, and all kind of things. So what you go is, I was just talking of a descriptive. So I have calculated the mean value, what is the mean value of the plant height. Then I have also calculated what is the minimum, what is the maximum. And then I have also calculated what is coefficient. So these are the descriptive statistics, suppose of 10 numerical characteristics of 500 lentil expressions kind of thing. So the first thing you should do is in descriptives. Of course, you should also calculate other variables, but these are the minimum descriptives you can calculate. Now you see, this is the correlations between these traits. Between these traits, how these are related. Okay. So if you look at it, that if you want to have, suppose yield per plant, if you are just trying to say, then it is like negatively correlated. But again, you will have to see that it is a low negative. This is a kind of an symmetric matrix. These values will be one or the same. So you need not, you will have to concentrate on that. So from here, you can very well see that which are the variables are positively correlated, which are negatively correlated, and then how so from here you can identify that important variable. Okay, these are the variables which are, suppose some of the variables are negatively correlated, some of the variables are positively correlated. So those kind of things you can look into it. Okay. Now coming to the regression analysis. When we talk of a regression analysis, as I said, again, you try to understand the average relationship between two or more variables in that. So simple, you have a y is nothing but a dependent variable, be it a yield, and you want to have x as a pod per plant, or x as a kind of what you say, pod per plant, or a fertilizer dose, or anything. Maybe y may be consumption expenditure, x may be disposable income. So it is simply a mathematical measure of the average relationship between two or more variables. So you can have only one x, you can have more than one x. And then we generally try to talk of a linear relationship, or you try to talk of a non-linear relationship. Those things are there. So whenever you have any such kind of things, first thing is that what is your hypothesis? Hypothesis is like pod per plant and yield. You expect that more the number of pod, more will be the yield. So this is your like statement that as it increases, the yield will increase. So this is your hypothesis. Now you try to specify the model. Specify the model means whether you believe that they are linearly related, or you believe that there is a quadratic equation relationship, or you know there is a polynomial relationship, whatever, or non-linear relationship. Then once you establish a relationship, or what you can do that you can collect the data and then you can plot a scatter diagram, and depending upon the scatter diagram you can specify the model. Then you estimate it, and once you estimate it, you test the hypothesis, and then you can use for forecasting and prediction. So simple thing. So suppose, as I said, you try to establish a relationship between yield and power per plant. Suppose you are interested in consumption expenditure, how much you आपका खर्चा माने कितना खर्चा होता है और आपका कितना इनकम है, इसका रिलेशनशिप। ये इस सबको पता है कि अगर आपका इनकम इंक्रीज करेगा तो कंजम्पशन एक्सपेंडिचर बढ़ेगा, लेकिन कितना, अगर ये आपका 1000 रुपया इनकम बढ़ेगा तो क्या कंजम्पशन एक्सपेंडिचर भी माने खर्चा भी 1000 रुपया बढ़ेगा? नहीं, लेकिन ये सबको पता है कि बढ़ेगा। अब कितना बढ़ेगा, इसके लिए सपोज आपने ये मान लिया कि ये लीनियरली रिलेटेड है, तो आप लिख सकते हैं कि जो कंजम्पशन एक्सपेंडिचर है, अगर कुछ भी इनकम नहीं होगा तब भी कुछ ना कुछ खर्चा होगा, इसीलिए हम एक इंटरसेप्ट डालते हैं। यू कैन ऑफ कोर्स, सो यू मस्ट अंडरस्टैंड दैट व्हाई दिस इंटरसेप्ट इज बीइंग डन। इंटरसेप्ट इसलिए दिया जाता है कि सब केसेज में इट विल नॉट बी पॉसिबल। सपोज आपके पास एक मशीन है, अगर वो मशीन से आप खिलौना बना रहे हैं, अगर मशीन चलेगी नहीं तो खिलौना नहीं बनेगा, तो इन दैट केस देयर इज नो नीड ऑफ इंटरसेप्ट। अगर आप कोई केमिकल्स डाल रहे हैं और आपके इंसेक्ट मरेगा कि नहीं, तो अब पॉड पर प्लांट और यील्ड, आपको पता है कि कोई पॉड नहीं होगा तो कोई यील्ड नहीं होगा, तो इन दैट केस देयर विल बी नो इंटरसेप्ट। बट अगर मान लो आपका एक्सपेंडिचर है या यील्ड है और फर्टिलाइजर डोज है, आपको पता है कि फर्टिलाइजर नहीं भी डालेंगे तो कुछ ना कुछ यील्ड होगा, दैट इज व्हाट इज कंसिडर्ड एज एन इंटरसेप्ट हियर। सो आपका डिपेंडेंट वेरिएबल हो गया, आपका इस साइड जो वेरिएबल्स होता है दे आर कंसिडर्ड नोन एज इंडिपेंडेंट वेरिएबल, समटाइम एक्सप्लेनेटरी वेरिएबल। तो डिफरेंट नेम्स हैं, जो y है उसको हम डिपेंडेंट वेरिएबल भी कहते हैं, एक्सप्लेन वेरिएबल भी, कभी कभी रिस्पॉन्स वेरिएबल भी कहते हैं, कभी कभी प्रेडिक्टेड वेरिएबल कहते हैं। इस साइड के जो वेरिएबल्स होते हैं उसको हम कभी इंडिपेंडेंट वेरिएबल कहते हैं, कभी हम एक्सप्लेनेटरी वेरिएबल बोलते हैं इकोनॉमिक्स में, कभी हम बायोलॉजिकल साइंस में कंट्रोल वेरिएबल बोलते हैं, बिकॉज हम उसको कंट्रोल कर रहे हैं, प्रेडिक्टर कर रहे हैं। तो what I'm trying to say that since there is no exact relationship, because आप दो लोगों में से दोनों का एक ही इनकम होगा फिर भी एक्सपेंडिचर अलग अलग होगा, तो हम उसमें एक एरर टर्म्स जोड़ देते हैं। इसीलिए स्टैटिस्टिक्स में जब भी स्टैटिस्टिकल मॉडल की बात होती है वी ऐड एन एरर टर्म्स। ये एरर टर्म्स टेक केयर ऑफ कि हमने बहुत सारे वेरिएबल छोड़ दिए या कोई डेविएशंस है, ऑल दोज थिंग्स आर बीइंग टेकन केयर ऑफ दिस। And as I said, you try to collect that, and then ये जो coefficients है दोनों का, ये β1 और β2, इसको estimate करते हैं। How we estimate it? There are different methods of estimation. एक जो common सा methods है वो least square। हम square of error को minimize करते हैं, जितना हम error बनाते हैं y and y predicted और उसको square कर देते हैं और इस square को minimize करते हैं, इसीलिए उसको हम बोलते हैं principles of least square। We are looking for that square जो minimum हो। आप मैक्सिमम लाइक्लीहुड एस्टिमेट, आपको उससे कोई मतलब नहीं, बिकॉज नाउअडेज सो मेनी सॉफ्टवेयर्स आर देयर। फाइनली आपको ये नंबर, आपको इंपॉर्टेंट है कि इस नंबर्स को कैसे इंटरप्रेट करें, ठीक है। तो पहले हम टेस्ट करते हैं कि ये जो 0.6 आया ये रियली डिफरेंट फ्रॉम 0 है या बाय चांस आ गया, तो उसको हम टेस्टिंग ऑफ हाइपोथेसिस। एक बार आपने टेस्ट कर लिया देन आप हमको इनकम बताएंगे, हम आपको प्रेडिक्ट कर देंगे। दिस इज व्हाट इज डन इन जनरल, दिस इज व्हाट इज बीइंग डन। तो ये 0.6 है, इसका मतलब है कि अगर ये फर्टिलाइजर डोज था और ये यील्ड था और दोनों केजी में था, तो मतलब 1 केजी अगर हम फर्टिलाइजर इंक्रीज करेंगे तो यील्ड जो है 0.6 केजी इंक्रीज होगा। दैट्स द मीनिंग ऑफ दिस β2 कोएफिशिएंट, दैट चेंज इन y वेरिएबल ड्यू टू यूनिट चेंज इन x, दैट इज द मीनिंग ऑफ द रिग्रेशन कोएफिशिएंट। अगेन उसी एग्जांपल्स को रिग्रेशन मॉडल, रिग्रेशन लाइन एस्टिमेट करने के लिए किया गया कि इक्वेशन क्या होगा, व्हाट इज द रिग्रेशन लाइन ऑन इट। सेम डेटा कि अगर बच्चे टीवी देख रहे हैं तो उनका टेस्ट स्कोर मंडे को क्या होगा। तो एक फॉर्मूला के बाद आप एक रिग्रेशन लाइन बनाते हो, तो यू हैव ए पॉइंट एंड यू हैव डेवलप्ड ए रिग्रेशन लाइन, और ये रिग्रेशन लाइन बन जाता है। इसमें कुछ आपको समझने की जरूरत नहीं। तो एक ये जो है इंटरसेप्ट हो गया, ये इंटरसेप्ट हो गया 93 एंड ये कोफिशिएंट्स हो गया। ऑफ कोर्स ये डायरेक्शन माइनस है तो निगेटिवली कोफिशिएंट हो, क्योंकि आपको यू नो वेरी वेल दैट देयर वाज ए नेगेटिव कोरिलेशन। अगर कोरिलेशन नेगेटिव हो रहा है तो नेचुरली है कि कोवेरियंस के कारण नेगेटिव होगा, बिकॉज स्टैंडर्ड डेविएशन विल ऑलवेज बी पॉजिटिव, तो नेचुरली वो जो रिग्रेशन कोफिशिएंट भी नेगेटिव होगा। एंड देन इफ सेकंड क्वेश्चन वाज दैट can you use this equation to find the expected test score for a student who had watched 9 hours of TV? आपको ये इक्वेशन मिल गया कि मार्क्स जो है अगर ये 0 आवर्स देखेगा तो 93।
Hello, sir.
Yes.
Sir, it is difficult to understand Hindi, sir. So please, can you explain in English?
Okay. Sorry.
Ah.
So it's as simple as that. Basically, what I am trying to explain is simple. That if you estimate a regression line, you have estimated a regression line, isn't it? So if you have estimated a regression line, y is a function of, so this some constant plus something into x. So x is 0. Even if suppose if you are watching the TV 0 hours, then you are getting this much marks. Now if you are watching as much hours, you are increasing, and you see this sign is negative, so you will be reducing your marks. So if you don't watch TV, you'll get a 93 marks, and if you watch 1 hour, you'll get less 4 marks, like this. So this is how you have estimated the equation relationship, and then you can predict it within the range for which you have collected data. Important thing is that your range of x is this, so your prediction should be within this range only. So if you are, so what is the message or model is this, that if you develop a equation for a particular location, and there the pods per plant varies from 10 to 20, you should not go to a location where pod per plant vary to 30 to 60. So that is the catch point. That is the caveat, means you have to understand that. Now you try to talk of a multiple linear regression model. In multiple linear regression model, again, as I said, that you have intercept, then first variable, second variable, and as far as you can go for a k variable. That is what. So it's a simple regression when you are trying to have a regression between x and y, and multiple regressions when you have more than one variable. And this had been done in case of an taking clue from a neural networks, but same kind of things, and then you sum over at kind of things. How you test that whether your model is good or not, you go for coefficient of determination. That is what is known as an R square. R square is simple. ESS means explain sum of how many you are able to explain, how much variation. You see, in the data, there is a variation, and you are trying to explain that variation with the help of some of the variables. So suppose there is a variations in the marks. Now you want to explain those variations with the help of the variable that whether that person has spent time on TV. You believe that the people who are spending time on TV on the last weekend for the coming weekdays, whatever exam is there, that is an important variable that you have understood through correlation. Now you want to quantify that how much it is. So you understood it that every hours you are watching, you are losing 4 marks. Simplest terms. So this R square is how much variability, because there is a variable. Whenever you have a data, there is a variability in the data. You are trying to explain that variability. Whole statistics is around that. So how much variability you are able to explain with this variable. So here it is explained sum of square, whatever value. So R square is 80%, means 80% of the value. R square, of course, it will be between 0 to 1, but you can always multiply in terms of the percentage. So it is, so R square is 0.8, means 80%. This means 80% of the variability in the data is being explained with this set of variables. That is the meaning of this. So again, for multiple linear regression, suppose you have developed a regression equations that yield of a particular, in this case, rice yield, depends on how much acres you have planted and how much acres you have harvested. Just a hypothetical example. So in that case, if you have been given that this much acres I have planted and this much acres I have harvested, and if you have any equations, you can always calculate this. That's the simple meaning of multiple linear. What you have to understand is that these coefficients are partial regression coefficients. They are as if others variables are. It is when I'm trying to say this I simply say that all others are constant, ceteris paribus kind of things. And then when you are talking of multiple linear regression model, now few points I want to say before I am closing this lectures, that you see, you get the data, be it a whatever data, be it a crop science data, be it a NRM data, be it a social science data, you must have to have a kind of descriptive statistics. And after that descriptive statistics, if you try to establish a relationship, if you have more than one variable, you try to find out the correlation, come for the regression. When you are coming for the regressions, there are basic assumptions of the linear regression model. And we say that errors have got. So I'm not saying that you should be, but you should try to run a kind of a robust regression. So here is the catch point. You must, as a biological scientist, you should interact with the statisticians, and you should try to work closely so that he will see that if he is saying homozygosity, he is saying all those things, how to take care of it. You need not have to worry about it. The assumptions are known. Again, violations, if there is any violations, how you can take care of it. Like one of the assumptions is that all exercise, whatever, suppose if crop yield is being explained by pod per plant or say plant height and all, you believe that all these explanatory variables are independent. But naturally, you know that some of the variables, sometimes what you are doing is, you may be taking the length of pod also, and you may be taking a kind of a grain, number of grains. So naturally, larger than length, larger the number of grains and kind of thing. So there will be a multicollinearity. So any two or more explanatory variables, and if they are highly correlated, if you just find out the correlation, if they are highly correlated, this means there is a multicollinearity. If they are very high correlated, you drop those variables, or you'll have to, there are other ways of that. And then heteroscedasticity and autocorrelation, of course, they are the problem. Another things in multiple linear regressions, if you are a social scientist, sometimes you get a nominal variable like gender of the head of the family, or size of the holdings of the farmers, and you do not know the exact size, you know only a small, medium and large farm. So you can go for a dummy variable. So this is all in terms of correlation and regressions, and I'm sure I have rushed to it, and many places I would have been fast, but I have closed from my side. And before I hand over to Dr. Kapil for practical illustration, that is what is the important thing. I'll request each one of you that within 5 or 10 minutes, you can fire some of the questions if you have.
Good morning, sir.
Very good morning.
Sir, if I get a positive skewness value and negative skewness value after descriptive stat, what it means, sir?
Basically, data is not normally distributed. Then most of the, you see, first thing is that you can talk about the data. As I said, if you look at my slides, I said that low variables are clubbed into it. So you can, something you can describe in your data. And second thing is that suppose it is highly positive or highly negative scale of data, then usual measures of statistics will not work. That is the only difference. So you are aware about your data. That's all.
Okay.
Am I clear or not?
Sir, I just want to know if the value is in positive, means skewness value is in positive and skewness value is negative. Then if I just do experiment on 140 genotypes and I take observation like germination percentage. And if I get skewness value is positive, what its meaning means higher, what is the number of higher values is greater, or the number of higher
Extreme
values is lower?
number of extreme observations are higher. You see, positive skewness means mean is positive skewness means mean is greater than median is greater than mode. If you look at the slides, then positive skewness and negative is positive means mean is greater than median is greater than mode. Negative means mean is less than median, and symmetric means mean equal to median equal to mode. So the moment you have a positively skewed data, so what happens? This means that low value are clusters on this kind of things, and you have you have some of the values, large value are scattered on the right hand side. So if it is highly positive, if it is highly negative, you have to bother it. But if suppose they are close to this, then everything that you can very well know from your histogram also. Same data you plot a histogram, you can know, and you can just overlay the normal distribution over there. Then you can very well know that whether you can go ahead with this or not.
Yes, sir. Sir, one question or if one variable is quantitative and other is qualitative, then how we correlate?
No, if one variable is qualitative and another variable, there are two things. First thing is that you cannot find out the correlations in this context. If at all, if you want to find out the correlations, then in quantitative variables also you'll have to make it a qualitative. Like suppose if you have data, suppose be it a yield from 10 to 30 kg. Now you make 10 to 12 is 1, 12 to this. So you make a kind of a scale, and then only you can do. But exactly qualitative, one side a qualitative, one side a quantitative, then you'll have to look for other kind of things rather than going for a simple correlation. Simple
Sir,
correlation,
like sir, yield is correlated. I just want correlation between the yield and the flower color, or yield and the seed color.
yield and the flower color, you cannot find out the correlations. There is no meaning, but you can always find out what you say, kind of association between attributes, kind of things. You try to find, because you see, most here in this case, if you find out the correlation, that will be completely a nonsense correlation. Fine, but you may try for kind of an association of attributes. Again, association of attributes assumes that both the traits are qualitative in nature, both the traits. So you see, both are quantitative, you can go for a correlation. If both are qualitative, then you can go for an association of attributes. But if you are looking at it, then either in the color you'll have to quantify it, ranking, and this, then only you can go with. Otherwise, you cannot find out the correlation.
Thank you, sir.
So, sir, actually, stats always seems complicated to us, but after listening to your lecture, I'm sure that all the training participants have understood it very well. So we greatly appreciate the time and efforts you dedicate to preparing such a comprehensive and informative lecture on correlation and regression. The session not only expanded our understanding of the subject, but also motivate us to explore the topic further. So thank you once again for sharing in knowledge and giving a great lecture. We really appreciate your help in our learning process, and we hope we can learn from you again in the future. Thank you very much, sir.
Thank you, Dr. Vijay. Thank you, Kapil, and
Thank you, sir.
to all the participants. Sorry, I had another engagement. That's why I'm leaving it. Okay,
Okay,
thank
sir.
you.
Okay, thank you, sir.
Now, am I audible? Now the practical portion will be covered by Dr. Kapil Choudhary. So I invite Dr. Kapil Choudhary for the further session. Dr. Kapil Choudhary.
Okay, thank you, Dr. Vijay. And now, meet you. Okay, audible? Okay. So let me start the practical session because sir has any meeting, so he can't continue the session. Otherwise, we will again enjoy his session because he has expertise in the R, because he developed many packages in R in the area of the economics, time series forecasting, deep learning models, and everything. So let me start and share my the screen to start our today's practical for regression and correlation. So. So as before start any R studio, we have to first of all clear over whether environment or plot and console. To clear over plot and everything, there is brush size, we have to clear it. And in the environment, again, we have a clear object from the workspace. We have to use the same brush. Now, if you want to clear the R console, then we have to use Control plus L, means clear the screen. Now our screen is clear and we can start. I try to explain all those things which have sir told in theory section. And before start, we have to install some packages. And after once we have installed, we have to run as a library. So first, there are two packages which are important for the correlation and regression. First is states and next is forecast. You have to install these packages in your R Studio. And if it is installed, there are two ways. Either you can install from here, otherwise you go to the packages and go here and type any name of packages. As the Rajiv sir told in your first class, that is like, I want to install forecast. So here you have to install the package. Once your package is installed, then it will become on the packages list. Like my package is here. I want to see whether my states is installed or not. Here states is installed. If it is not blue tick, means it is not marking tick mark, then you have to tick mark to use it. Otherwise, you also can use it in library states. The work will be same. Another package is like, I want to see whether my forecast package is installed or not. Then here is my forecast package. Again, it is tick mark, means I have used the library. Okay, so these both the packages we will use our next session or this session. So before start our session, we have to import the data. For this, to understand the correlation and regression, I taken an agriculture data, means data is collected from a pilot survey on a hybrid jowar crop. The yield and biometrical characteristics. Here, yield is my dependent variable and biometrical characters are the independent characters. Like here, I taken some biometrical characters like population, plant population, first PP. Second is average plant height, that is pH, means pH means plant height. Actually, I use pH, PP like such type of words in my this script. Next, biometrical character is average number of green leaves, NGL, number of green leaves. And final, my dependent variable is yield. So these are the variable or such a type of data I have taken in an Excel file. Okay. So before you have to import your data. Now there are two options to import your data. First is either by you can use your coding, or you can go to environment section. Here import section is there. Now suppose my file is in text file. So you use your text file. Otherwise, you have an Excel file. You can also use an Excel file. But I want to use my coding. Through coding, I want to import my file. So first of all, you have to use this code, because I name my data is a correlation regression. Next, this is command read.csv and file.choose. So once I run this code, he asking me where is your file, and I give him location. Suppose my location is like this one. Here is my data is mentioned correlation.csv, means it data. Now I want to open it. Means data is imported in my R Studio. How we say that my data is imported or not? Because in, as we can say in the console file, here it is green, everything is written in green. If something error is there, then it will be written as in red line. Okay, so my data has been imported. Again, we also can verify whether my data is imported or not in environment section. Here, as it mentioned that correlation regression, it consists 46 observation under 4 different variables. which are 4 different variable. One is my dependent variable, that is yield, and another 3 are my independent variable, that are PP, pH, and NGL. Okay, but I want to see whether my data is imported or not again. Then I only run this one because I gave the name data is as a core regression. Core means correlation and regression. Okay, so I again run here, and as you can see here that PP, pH, NGL. These 3 are my biometrical character as independent variables, and final are yield is as a my dependent variable. But again, if I don't want to see my full data, and as I want to see only upper head and lower depth, so I can also use as a head, give your data name, means my data name is co-regression. Okay, co-regression. So if you run this one, means only 6 line it will show you. And if you want to see your tail of your data, then use tail and give your data name co-regression. Okay, so again it is your term, means again it will be show your heading, means what the variable you name, input your name in your Excel file, and it will show your last 6 observation or 5 observation, like this one, means 46 observation of the PP is 89 and pH is 0.49, like this one. Means still we have only imported our data. Once you imported your data, now first operation we will do, find out the correlation. Before correlation, means first of all we want to find out correlation between each and every variable which are used. There are different 4 variables, means correlation will be get. So I run the code for the correlation. There is function core, COR. Okay, if you still confused it how to use the function, then above you can see that core bracket x comma y null and all this, but still it is not clear. Go to help file and search here core means core is there. Okay, once core is there, again like here, as you can see, core bracket states, means states is our package and core is our function. Means under the states package, because packages are different, packages are there. Okay, so under the states package, correlation function is there, and that function we are going to use for our analysis. Okay, so core bracket core regression. Why we use core regression? Because again it is my data name, so I use core regression. And if run this file or this code, then we got such type of thing in our console file. What is this? This is my all R4 variables, including my dependent and independent variables. So first is the correlation. I want to find a correlation between PP and PP. So variable will be same. So then the correlation will be 1. Exactly, perfectly correlation. See the correlation between but if I want to find out the correlation between PP, means plant population and the plant height, then you have to see the first line, plant population and plant height. This is correlation is 0.2396, means correlation is positively correlation. Next, if I want to see the correlation between PP, means plant population, and the NGL. NGL is over 1 second, variable name is NGL, number of green leaves. Okay, so number of green leaves. So PP and NGL correlation is 0.28, means again it is a positive correlation, and the correlation between PP and yield is 0.3859. Like it is again also positive. Same way it will be go on column wise and row wise. Again, if you want to see the PP and pH here, same way, because this value and this value is the same. It is just nothing but a matrix after run the correlation. Okay, so after the correlation, if you want to, means this you have find out the correlation, but if, as sir told, that before run any analysis, you have to also perform a scatter plot to be different between different dependent and independent variable. For this we can use pairs dot correlation regression. As you can say here, PPPH means it is the graph of different and among between different group, whether dependent and independent variable. Okay, so again, we have, suppose I am interested only find out the correlation between 2 variable. My interest is find out the correlation between yield and PP, whether it is yield and pH. So before proceed further, we have to extract these PP, pH, NGL and yield variable from our original data set, and our original data set is correlation regression. So to extract each variable, we have to run each line. like first line is my PP, means I want to extract my PP variable from our correlation regression. So I run as a PP equal to co-regression, means here you have to mention your data name, means I as starting I given my data name as a co-regression, and in bracket you have to comma one means you are extracting your full first column, means extracting first column, and it will be your PP. If I run this one, then as you can see in console, there it is extracted from our correlation regression data. Next, if I want to extract our PS data, then how will you extract it? Again, means you have to mention your data name and bracket give comma 2. 2 means I want to extract second column, because I know my second column is pH data. So again, I run it. It is pH. Same way we proceed for the NGL and yield. Okay. Now, if you want only correlation between PP and pH, so I run this file. Means here, as you can see, I only run core in bracket all data, means full data. This is my full data, but instead of it, I also want only want means the correlation between my PP and PS between two variable, any two variable. Okay, so it is core bracket PP comma PS. So it is here my value is 0.2396. As you can see in the matrix, 0.2396, same value. So means if is your, again you can change any variable, like if I want to check the correlation between PP and yield. Yield means YLD. Always remember that RStudio is a case sensitive. So whatever the variable you mentioned earlier, means suppose I mentioned here YLD, okay, but here I forgot and I use YIELD, okay, means I use full name, then it will be show you a error that the data frame is not found. Why? Because you have not defined any yield variable, okay, but here as you define or only yield. So always remember that is RStudio is a case sensitive software. So you have to use whatever variable you define in your previous script. So use the same variable and run it. Okay. So again, now it is okay, because now he find out the yield variable. Okay. And here, as you can see, the same correlation 0.389 and 0.389. The correlation between the PP and it. Okay. So basically, this is Pearson correlation. I told you that we find out the Pearson correlation. Mainly correlation was given by the cold Pearson. Okay. So these are Pearson correlation coefficient. But suppose we have different, like if we have rank data and other data, rank data. Suppose we have rank data, then how we find out the correlation between two? Like sir told the example of beauty and brain, like this one. If you rank two things, means judge intelligence, like this one. So how you find out the correlation between these two things? So for that you have to use Kendall correlation. So here how you use Kendall correlation. Before it, if you want to plot only PP and pH, or you want to plot only PP and yield, like this, for run this, you have to find out this. This is your PP, sorry, pH, and below it is your PS data, PP data is there. So on x-axis it is your PP, and on y-axis it is your PS data. So suppose we want to find out the correlation between, suppose my data, suppose this is my actually quantitative data, but if my data is qualitative, and again the data is arranged in ordered way, means it is so how I proceed for the data? As you can say, see in the above yellow color text here, the bracket xy equal to null, my use equal to everything method equal to C, Pearson, Kendall, Spearman. If I did not mention any name of the method like Pearson, Kendall, Spearman, it will be by default give me a Pearson, because Pearson give us a default, because he is the for given the correlation. That's why he by default is the Pearson. But instead of it, I want to find out the method of Spearman. So how you will proceed is, again you have to find out the correlation between PP and pH. Here you have to mention like comma method equal to, here you have to mention the method Spearman. So here you have to find out the, means if this line we have to run, then as you can see in the console, we find out the correlation between 0.221. But our data is not order data. But if you have got any order data, you have to run the same way. Okay. Now, once you have find out the correlation between any two quantitative variable, means correlation is nothing but as a linear association between two variables. And if you want to test, statistically test whether my find out whatever the correlation I find out between any two variables, whether it is a statistically significant or not, because in statistics we talk about in terms of the significance. Okay, so for every statistics we have again a significance test. Okay, like for correlation we have again a statistical test. Here we mainly use t-test for the significance, whether my find out whatever I find out the correlation, it is significant or not. For this we have to run a t-test. Okay, for this not you have to run directly t-test, but here as given core test, like core test. So you want to find out the statistical significance between pp and ph, whether my correlation is significant or not. If you run this one, here can see that my correlation is this one 0.2396. Okay, but whether it is a significant or not, it is a p value is 0.10. Means if my p value is very less than, then I can say it is more statistically significant. If it is more, then I can't say that is as much as significant as it should be there. Okay, so here value is 0.10. Okay, so it is not as much as significant as it should be there. If it is my, suppose my p value is 0.005, then I can say it is a strong correlation, means correlation is there and definitely statistically significant. Okay, and so okay. So correlation is over. If you have any doubt in correlation, you can ask. Otherwise, we proceed further for the linear regression.
Hi, sir.
Speak.
Hello, sir. What if one variable is ordinal and one variable is nominal? Which correlation should we use?
No, actually, you have to, means if you want to find out the correlation, both the variables should be in quantitative nature. Okay, means it should be, means if how you can find out that, again sir told in theoretical class that it is a, we call it a spurious correlation, means nonsense correlation. We can't directly find out. For that you have to go for a method of attributes association scheme is there. Under that you have to find out, but directly correlation you can't find out.
Okay, sir. Thank you.
So okay, so now we come to the linear regression. I have used the same data, means now my again dependent data is yield and independent variable as a pp, ph and lgl. So I find out the correlation, means there is positively correlation. As you can see in this matrix here, every correlation is my positively correlation. Okay, so I now I have to run the regression. In regression, how I going to predict the yield and on the basis of my independent variable or explanatory variables. Okay, so in regression, as I told, there are two types of regression, means linear and non-linear. In both the cases, we use simple and multiple. So we will start from simple and we will proceed further to find out the multiple regression. So first of all, to find out the regression, simple regression, here only two variables, one dependent and another is independent. Okay, so here my dependent in this data set is my dependent variable is independent. So dependent is yield and independent variable is pp. Okay, you can also check the pp, ph, ngl, any variable you can take. But remember, it is only simple regression. So you have to take only two data. Okay. So I again run, means I gave a name of this model as a rig. Okay, you can give any name. Okay, no problem. But remember, you can give any name to this model or anything, but don't change the name of formula. Okay, means if the function, if you change the function, you will not able to find out the same result. Okay, because if the function is exists and you install the package, then it will be run. Otherwise, you enable to handle means find out the analysis of any type of. Okay, so before find out the regression, so here we will use the lm function. Lm function again here given the formula, comma data, comma subset weight, means there are different attributes are given in the same simple formula. You use as much as you want. Okay, but if simply you want formula means what formula I'm going to use, means my dependent variable is dependent on which variable, on pp. It is my simple regression, it is my simple formula. And before you used to define a formula, like suppose 1 second, I explain in the table. So suppose y equal to like my yield is dependent variable and independent variable is my PP. Okay, so it will be my formula. But before in formula, as I told in the class, that you have to formula like this one, y equal to a plus bx. So bx, okay. So my x is PP. It is my explanatory variable. Yield is my dependent variable. It is over. But how we will find out a? It is my plus, okay. It may be minus. If my b, we find out b minus, then it will directly change b, okay. So b may be minus, okay. So it, I only fit the formula this one, yield equal to PP, and my software will find out for me value of a and value of b, okay. So in means it is directly, I only fit this formula, but you have to estimate these value a and b. As I told in there is formula for a and b, like a equal to y bar minus b into x bar, and for b is equal to summation of x y upon summation of x square. It is difficult to understand all these things for a non-station person, but you directly use the R package and you will find out all these things. Okay, so here I use the code is LM yield equal to PP, because as I told you, it is a simple regression. So here we use only one independent variable. My dependent variable will always be one. Okay, but independent, if I increase the number of independent variable, then my model of simple regression will change from simple regression to multiple regression. Okay, so once I run it, this one, okay, means model is run. Now I want to see what is the summary of this model, okay, regression. So as you can see here, whereas I use this formula, yield equal to PP. Okay, what two things I am going to estimate out of this thing? As I told you, one is intercept, another is the coefficient of my PP. Okay, means suppose I simply use a model equal to y equal to a plus bx. This is my model. Okay, so first we find out of this analysis is a, and second is b. My a is 0.83, okay, and my PP is 0.1. These things we find out directly if you run directly LM. Okay, now I 0.83 and 0.16. Suppose 1 second. Again, y equal to a plus bs. Okay, so I find out these values like this. I will find out 0.83 and this value is 0.1. Okay, this value I find out from the regression. Okay, y is my yield. Okay, so now my model becomes 0.83 plus 0.1 into x. X here I am taking as a PP, plant population. Okay, now suppose this is my fitted model. Okay, my fitted model. And the analysis through the R, we find out these both A and B. Now suppose someone asks you what the value of yield if I given you this yield, this PP. Suppose my PP is 10, my PP will be 12, my PP will be 40. Okay, from existing data, whatever the 46 observation we have obtained, you obtain this model, but it is my unseen part. Okay, suppose someone come and ask you if my PP value is this, that's 10 value, then what will be my yield? So according to this data, you have to predict the y. Means y, you are going to predict the yield. Again, it will be 0.83 plus 0.1, 0.1 into 10 and equal to 0.83 plus 1 equal to 1.83. So my yield will be 1.83 kilogram per plot. So it is the prediction, how we predict from a given regression model. Okay. So again, you can see the summary. If you want to find out the summary of my model, then you have to rig. Means rig again I am using as a model. Okay, name of model. This is my summary of the model. What things we are going to find out from summary of the model? There are two things. Coefficient. What are two different coefficient? Means A and B. A is my intercept. Okay, as I told that if we going to provide nothing in field, if you don't use any fertilizer, suppose PP is my fertilizer. Okay, if you don't apply any fertilizer, definitely you're going to get some yield 0.83. That is your intercept. Okay, it is your intercept and it is your PP. Again, it is a standard error. T value actually for the in correlation we use t test for the statistically significant. Again, the same test we are going to use in regression, statistically significance, to check the statistical significance or not. Here, as we can say, my intercept is not significant. Why? Because its probability value is very high, and that's code for the significance are given below, like here. Like if it is 0, means nearly 1%, below 1%, if it is there, then it will be marked 3 star here. Here it will be marked like this. If my probability value is less than 1%, then it will be marked 2 star. Here 2 star. If it less than 10% as 1%, then it is 1, 5%, 10%, like this one. Okay, it will be increased. So here, as you can see that it is 2 star, means my coefficient is significant, but my intercept is not significant. Okay. Next, here, once your model is fitted, then how you say that my fitted model is best or not, means existing model, or even though this fitted model is good or not. Okay. So there are different testing of the model. Like first is residual standard error, means whatever the fitted model, we will find out the residual. The residual is nothing but the observed value and predicted value differences. So it is my residual, and we have to find out the residual standard error. That is 1.36 on 44 degree of freedom. Means here 44 degree of freedom means actually my observation is 46. Okay. Then the formula of the degree of freedom is n minus k minus 1. Okay. N is my number of observation, minus k means my number of independent variable. As I use here only one independent variable, and minus 1 means 46 minus 2 equal to 44. And degree of freedom is nothing but a number of independent observation. We have no restriction. Actually, once we have imposed one restriction only, what is the restriction? That my explanatory variable is pp. Okay, I pose one restriction. This rest of data is my independent. Okay, this is my degree of freedom. Okay. Again, next adequacy test for the regression model, we use multiple R square. Means R square test. Here R square is my 0.1489. 1.8, as I told, it range from 0 to 1. 0 to 1 means if it is near to 1, means my explained, means the model explain much through the pp as a independent variable. And if it is low, means still there is lacking of information which we require to input in this model. Okay. And second is adjusted R square. What is the adjusted R square? Suppose I increase the number of explanatory variable, then definitely my R square will be increased. Definitely my R square will increase. Suppose like if we take example of weight, if we eat more, then definitely our weight will be increased. Suppose this is an example, but whether if we in same case here, like R square, if we add more and more explanatory variable, means independent variable, then our R square will be increasing. But it is not correct method. Okay. So instead of R square, we should to use adjusted R square. It told you the included variable is significant or not. If it is not significant, then it will be not increased. And in general cases, adjusted R square is lower than the observed R square. Okay. So these are the statistics, and through ANOVA, we find out these things for a simple regression model. Now, again, if you want to change the model, like if I want to run another as a pH, okay, so you have to regression equal to LM yield equal to pH. So this is my model. Okay. Now, as you can see here, in last model, here my R square is 0.14, but again, in this case, my R square is 0.11, lower than the previous model. Okay. So again, here, as you can see, like my pH, both are in 1 star, means now the model is significant. Both the coefficient are significant. At what level of significance? Like less than the 1% level of significance. So this is, we can change any variable like NGL, all these things. But always remember, my dependent variable will not be changed. You can change your independent variable. Once your simple regression model is over, now I'm going to add more independent variable instead of only one variable. Okay. Here I'm going to use a different variable. Like here I use only one variable like pH or pp. Okay. But here I'm going to use pp, pH, and LGA. Okay. So I run same model, nothing, no function change, nothing else change. Only I change name, means model name change different. M regression. M means multiple regression. Okay. So I run this model, and once I run this one, I find out the coefficient, okay, but I want to see the summary, means related to regression or analysis, okay. So again, there I find out these summary for the interpretation will be same like in previous simple regression model. In previous regression model, only we find out these two rows, okay. Why? Because there we only have one independent variable. But in multiple regression, here we use three different independent variable. So for three different independent variable, we have to add two extra independent variable, and for these we have find out these two extra rows. Okay. So these are their estimated value. Estimated value is nothing but in the model, what are the value we putting to find out or we predict over yield. Means in previous model, as we can see, y equal to a plus bx, then a and b. If we fit our model, then we predict or we estimate these value a and b, and the estimated value is like minus 8.4, 0.1. As you can see that all these value are positive. This means for the coefficient for pp, it is also positive. For pH, for NGL, everything is positive. Why? Because in correlation, as we can see, the correlation is positively correlation. Means once if my pp will be increased, then my yield will be increased. If my pH, same way we can say that if my NGL is increasing, then my yield also going to increase. These are the other statistics which we used for statistical significance or not. And finally, these are my probability. Okay. At what level of percent we can say which variable is significant or not. Suppose I want to remove this variable, okay, and before it, you please see the r square and adjusted r square. Here my r square is 0.23. Here, what the meaning of 0.23 means? Only 23% of variability explained by these three variable independent variable. Okay, means still there is variability remaining in the plot or field, means we have to include another variable also to increase this. Okay, suppose I remove one last number of green leaves, I remove from our model. Okay, and if I run, then the what will be effect on our, okay, here as you can see, like my one second, here my r square value is 0.23. okay, when I using 3, but if I am only using two variable, then my r square is decreasing. Okay, and again, like as we use in a simple regression model, my r square is again decreasing. Means if I using only one variable, my r square is 14, means 0.14, means it is saying that only you have 14.89% of variability explained by your independent variable. Here, only 21% of variability is explained by your independent variable, because you have two variables, means r square is going to increase, and here is my 23% of variability is explained by three variables. So it is a positively correlation between the r square and the number of explanatory variable. But it is not true in the case of your adjusted r square. Adjusted r square only will increase whenever added variable is statistically significant or not. If it is not, then it's not going to be increased from its value. Okay, so and it should be high. If you check the model adequacy, we have to find out that these values should be high. Then we can say that our developed model is good than the existing one. Okay. So once you have estimated your parameter, and if you want to find out the confidence interval, at what range these confidence intervals should be like, then for this you have to find out, one second, NGL. Okay, this is my model, final model. Okay, now if I want to find out the confidence interval for the regression parameter, and it is, if I don't mention any level of level like 95%, 80%, 85%, then by default it will take 95% of confidence interval. And if I will mention 90%, 85%, like any value, then it will be according to that. Like here I nothing mentioned, then it will be, we will find out the confidence interval for the regression parameter at 95% of levels. Here 2.5 means one-sided. If we said added both the side, then it will be 5%, and 95 minus 5 plus 5 equal to 100% of them. Same case, if you use as a 90% of level of means it is a confidence interval, means lower value intercept value will be this one and higher value will be this one. It is a confidence interval, means among these values our intercept value will be like. Okay, same case for the PP, PS, and NGL. Okay, but if I change level as from 95 to 90%, then what will be changes in our result? These are the changes. Okay, here 2.5% because it is one side, as I told you. Then in both the side 5%, but here 5% one side, then both the side 10%. Rest of remaining part is 90%. Okay, so once you fit your model, everything is good. But how can again we say check our adequacy, whether the overfitted model is good or not? So for this, you have to first of all predict our values. Okay, so there are two ways of prediction. Either means suppose I given here as I given yield, PP, pH, and NGL. Okay, so it is my given data. Okay, from 1, 2, 3, 4, 5. These are my given data. Given data, suppose 2, 3, 4, 6, 8. These are my yields. Okay, at some level of PPPH. Okay, something. Okay, this is my observed data. Out of this observed data, suppose I fit a model y equal to 0.83 plus 0.21 PP plus 0.45 pH plus 1.2 NGL. Suppose it is my fitted model. These 0.83, 0.21, 0.45, these are nothing but the coefficient as we obtained from the regression analysis or by using the LM model. Okay, so once my model is fitted, then if my sixth observation, I want to predict sixth observation. Means prediction means you don't have any, okay, but you obtain data from like PP, pH, and LG. Okay, so if you have these things, then you can directly predict the Y. So this will be my yield may be 9. If something by PP value is anything, or it is observed data. Okay, so it will be my predicted value. It is future predicted value. Okay, this is one way. This is my unseen part. Okay, but I also can predict for the seen part also to check my model, whether my fitted model is good or not. Okay, so suppose I fit this model from these observed data, and I'm using again the same given PP, pH, and NGL, and here I am written as a predicted data. And here my value may be 2.6, 3.9, 4.8, and 9.2, 10.5. These are my predicted for the same part. Here, as you can see the difference. Here my actually yield is 2, but my predicted is 2.6. Maybe it changes because we can't exactly predict anything. So here my actual data is 3, yield is 3, but here as you can see 3.5 and 4.8, 4, 9.26, 10.5. So these are my predicted value for the given data. And the same thing, what are the differences there? 2 and 2.6 is 0.6. That is my residual. So we will test some QQ plot, NN plot, LM test for the residual, whether my residual follows some assumption or not, which are set told in the last slide, like multi-collinearity, ectosidicity, autocorrelation, all these things. Okay. So it is a basic structure. So here, as you can see, that is first is prediction. Prediction equal to, you have to use predict. Now again, you see the where is the predict, in which function or which package we are going to use predict. Okay, here as you can see predict. States means again it is the function in the states package. Okay, so I'm going to use the predict, but what I'm going to predict? AM regression. AM regression is what? My fitted model, AM regression. Okay, so once I run this one, I find out the predicted value for all 46 observations. As you can see here, 41, 42, 43, 44, 45, 46. Same way. Again, some residual also I will find out for all the 46 value. So these are my residual. But now I can plot something to test whether my fitted model is good or not, like this one. So first of all, I plot all the value of my predicted value and residual. And next is QQ norm, because QQ norm, why we fit the QQnorm actually fit to test the adequacy of the residual, whether the residuals are under normal or not. It is not necessary case for the forecast. If you want to forecast, you can forecast. No issue. Means these assumptions we only check for estimation, not for forecasting. Okay, so you can use, as you can see, my line in graph is only straight line. All observation, all the residual are lying on this one. Means it is symmetrical residual is there. Okay. Now, if I want to check the residual through SCF plot and residual plot like histogram also, then this is the graph. SCF plot and the residual. Okay, as you can see that it is my residual. So suppose I have 46 observation. For the each observation, I have obtained some observation, and actually these residuals should be hovering to or nearby 0. As you can see, it is hovering 0, 1, 2, 0, 1, all these things. Okay, and it should be. Then my fitted model is good, otherwise not good. Okay. Second is SCF plot. In SCF plot, what the SCF plot told us? It told us that at what leg these are correlated, means at what observation. Suppose here, as you can say, this line is going out of the box, means this leg, this time it is significant. Okay, suppose rest of thing is under the blue line, means there is no autocorrelation, or ACF means autocorrelation function. Okay, ACF autocorrelation function. So here we try to find out that means there should not be any line go out of the blue line. If it is going out of the blue line, means it tells us that there is significance of autocorrelation and there is something is there. So you have to find out the remedy. You have to again test for the SCF plot and convert your data and other procedure. Next is the residual. In residual, it is my bell-shaped curve. It is my normal curve. Okay, but the observation lies, most of lies on the left-hand side. Means it is a positively skewed data, but little bit, not highly positively, but normal. But it should be normal actually according to assumption. Again, I'm telling the assumption does not affect your forecasting, but they are problematic in your estimation. Okay, so these are things. And finally, if suppose I want to eliminate my starting part like that, like this one, suppose I want to eliminate my intercept. Okay, so if I want to eliminate the intercept, how I will run the model? Means again I form a regression model, multiple regression model, but I gave a name, a different M regression one. LM is function, yield my dependent variable. Here I given -1. -1 means I don't want intercept. Okay, so if I run this function, and as you can see summary, if so, summary M1. Okay, as you can see here, we did not find any intercept term, because if my intercept is not significant, I want to eliminate it, then go for it. And here, as you can see, your multiple regression R square is 79, means these variable explain nearly 79% of variability. Means the rest of is there. You cannot include everything in your model because cost and time is always a barrier for every researcher. So we can't use everything, but these are the simple regression. You use any type also data. Actually, I have taken another data also for consumption as stored in consumption data, because my income and consumption. So you can run this data also, because it one library function is there, FPP2. So we will run the same thing in, again same thing, no changes are here. So again is a library like FPP2. I directly very fast, going too fast. It is my data like consumption and income data is there. And if I'm going to fit at this line, that what will be my intercept and what will be my income coefficient is there. Okay, and if I include more variable like independent variable like income, production, unemployment, saving, all these things, then what will be my model? Then this is my model. These are the intercept for the income. This will be my coefficient, all these things. Okay, some are significant, some are not significant. Okay, if I'm going to plot a predicted value versus my fitted value, means these are my data, actually observed data, and through my fitted model, these I am going to use. So why I'm using such type of thing? Because if I'm going to in future I'm going to forecast something, then this will helpful for me. If it is your good fitted, means the object value and fitted value are very close, so it is your model is good. And again, you can check your evaluation of regression model through check model, as you can see here. all value are orange through 0, nearly 0. Means residual is very less. Means residual means whatever the original value you obtained and whatever the residual, sorry, predicted value, they are very close. Means the difference is very less. And it is SEF load again is significant, no issue. And your residual observation are in follow a normal graph. That is it. So this thing we have to cover in this one. If you have any query, then you can ask. Otherwise, thank you.
So now the session is open for discussion. You can ask your doubts.
Hello.
Hello.
Sir, how to perform logistic regression function with the help of R Studio?
Same way. Actually, in logistic, your dependent variable will be in binary string will change like 0 and 0, and dependent variable in same way. So for that function is same, will be same, but you have to obtain your data will be different. Logistic. Hmm.
So is it possible to perform with this R function?
No problem. No problem. You can rename model dependent variable this one, but it will be logistic. Okay.
Command will be same, sir.
No command will be there is different function in state function. Okay, you go and search their function.
Stat
Logistic
function.
one. State in state one.
Okay, sir. Thank you.
So thank you, Dr. Kapil, for giving us an excellent and practical lecture on correlation and regression analysis using R. Definitely our participant learned a lot from this lecture and found it very useful. And another thing is that all the recorded lecture will be available on our YouTube channel. So we will share the link, and all the codes will be shared through the email to all the participants. So we will meet again at 11 a.m. tomorrow. Thank you, everyone. Thank you.